All right. This week let's do something a little bit different. Not a real formal tutorial. But what I like to do is talk about these dummy models that you can basically download and how to put them into a model that you want to play with. Now, obviously, there's a much better way than what I'm gonna present, but what I'm gonna present is what's available to me, and I find it interesting that we can download these vehicle and these dummy model, these heifer models from LS-Dyna, and then we can just do things with it. I find that it's just so fascinating, and I want to talk a little bit about how to do that and just have a recording of the basic steps and thought process that one must go through. Now, you could do it many other ways than what I've done. What I've done is not necessarily the best way, but hey, let's take a look. All right. All right, so this is the final version. I'm gonna do a model like this as part of the demo, but I'm not gonna go through all the steps. I'll go through the basic steps. Now, for something like this, you can sort of see in this website right here. You see all of these little different model that you can download. These are the Answers has done a really good job incorporating into their own website instead of in the old FTP website or whatever. Now you have this in a pretty decent place where everything's pretty organized and you can download any of these. Now, what I've downloaded is a 95 percentile uh, model like this. I think it's a male. Um, let's take a look at what it is, right? So if I just load this into Alice prep post real quick. One second. So where did I put that file? All right, right here. Drop it in here, and you can sort of see what we have is a model that look like this, and you can actually adjust the joint positions in any of these. It's really interesting if you play with that, but I'm not going to talk about this. I'm actually just going to exit out of here without adjusting any position. You can see this is a seating, a human body model that's sort of sitting down on something, right? And what I'm gonna do is that I want to put this onto a table, well, onto a chair that look like this. I just drew this on myself, right? So how do you put a dummy model over here? What's the right step to do it, and what are the ways in which you have to what are things you have to look at in order to be able to build a model in which the seed will accelerate and suddenly stop. And when it does stop, you have a situation in which you can look at, like the way the stress on the beams perhaps, or maybe you can look at how the human body behaved. It's mostly for demo purposes. Like, obviously with this kind of implementation, you can do more serious studies if you wanted to do that. Okay, now with something like this, right? There's a lot of stuff going on in these dummy models. If you ever study them, it's actually really fun how they did this. It's an entirely different topic to deep dive into how these things are done, the amount of work they put into it over the decades, right? It's probably way before I started doing this. They already had this ready. Now, see 2013. Now, with something like this, only thing I'm gonna do is that I'm gonna export the geometry from file save as. I'm gonna export the geometry as an STL file, which is essentially a faceted model, right? A faceted model. I'm just gonna save it, call this the save dummy, and I'm gonna save it out. And you can sort of see now I have a model has been saved out, right? And if you look at my demo model, I now have a save dummy.stl, and now I'm gonna exit out of here. I don't need anything else from here for now. Now with something like this, right? If you take this to SolidWorks or to any other CAD program, you can actually import. I'm gonna open up a part, and I'm gonna drop this in here. I'm gonna drop this in here, and what you'll notice is that you will actually load a facet model like this. Now you can actually right click and then convert that to mesh. I believe you can do that. Well, either way, but something like this, you can sort of see it tells you the geometric position relative to, say, for example, the global coordinate system, right? So if I were to draw around what I'm looking at here, right? I can basically create a model in space relative to the position of the LS-Dyna dummy model. And of course, I can transform the LS-Dyna dummy model, translate and rotate it to get it to a position. But in my opinion, it's actually way easier to import the original LS-Dyna model into a CAD program, look at its geometric position visually, right? And then you can then draw around it using your CAD package, and which is what I've done. So for example, uh, if I were to unsuppress these, um, oh, I'm sorry, if I were to suppress these, and let me hide the Let me show this, and then let me show this. Oh, did I? Oh, I think I might have missed something. Yeah, I did. Okay, sorry about that. That was a mistake. Okay, now I have my full dummy model in here, right? I'm not gonna use this facet value for anything. This is entirely useless to me. In every way possible, it's entirely useless, right? But I can sort of see, you can sort of see what I did was I drew a chair right around the dummy model. I can actually put you can actually design seat belts and stuff like that if you want to, but in this case, it doesn't really matter. And then what we have here is basically something that look like this, and you can sort of see this is what's happening, right? This is sort of what's happening in the uh, in the full model right here. Let me drag this out. Sorry about that. I'm gonna clean up my cat a little bit. Now with something like this, you can sort of see I now have a chair. I now have the dummy model. So what can we do with this, right? So what we can do with this is that I'm gonna go ahead and resuppress my model, so I don't have my dummy anymore, right? And then I can save this. I can essentially load this into SpaceClaim that look like this. So I already loaded this here. I'm just gonna show you inside SpaceClaim what happens. And this is an extremely simple dummy model. There's no real value behind it. Um, but what we can actually do with something like this, right, is you can build your Dyna model the same way you would do it any other way. It doesn't really change how you set up a chair model. I mean, chair model is really basic, and all I'm gonna do here is I'm just gonna no merge everything. I don't want to do any content. I'm just gonna no merge. You're gonna make the mesh a little bit less clean, but whatever. Right? It's a pretty simple model. All right, I want to get out of here, and let's get back into Dyna. Now into Dyna, what I already have inside this template file, because I already built a model. I'm not gonna show you this one. I'm gonna show you this one. So I'm not gonna do it from scratch because I want to save some time. There's no real reason to go through individual steps of doing a stupid chair model, because it's very simple. But what I do want to show is what happens after you build your baseline chair model. How do you get it to work with the dummy model? Like, what are the things you have to do? That's what I like to focus on, right? But for something like this, sorry, it's loading. Give it a second. This is why I don't like to do video while it's loading. It's kind of silly, but hey, it is what it is. So let's wait a little bit. All right, it's loading over. Good. All right. Nothing to it over here. All right, so this is the chair model, and I'm just gonna assign some dummy material to all of these. It doesn't really matter. I want to put a remote point, which is a CNRB in Dyna, into the bottom surface. I want to make sure it's located properly. And on the mesh side, I'm just gonna mesh everything with 20mm mesh. It's just gonna create a mesh that look like this, relatively clean, nothing to it, right? All right. Once I have this, what I'm gonna do next is that I'm going to look at my initial velocity. Now, for something like this, interestingly enough, right, you don't actually need to use the initial velocity like this. I'm actually going to suppress it. The remote displacement on this remote point just keeps it so that it only moves in X direction, right? So when I generate a translation on this remote point, it only moves in X direction. So what I wanted to do is have initial velocity and have it come to a sudden stop, and that generate that force, right? That inertial force on the human body as well as on the anything that's not the floor. Like this body right here is the floor. Anything that's above the floor is gonna see that sudden stop as a force, and then you can sort of look at what the response will look like. Now, in terms of the deformable body, I like to make this piece deformable, and I'll explain why that is later. And everything else is super simple. Okay, so the reason I have, oh, this is about 100 millisecond, and I'm doing the solver units at millimeter, millisecond, kilogram. Now, the reason it's millimeter, millisecond, and kilogram, and cannot be anything else, is if you look at the dummy models, right? If you look at the actual dummy model that I was showing you earlier, um, if I load it in here, you can sort of see the units is in millimeter, kilograms, millisecond. Now the reason is like this, because the dummy model is in this unit, the Dyna model for the chair has to be in that units. Otherwise, you're gonna have a scaling problem. Like for example, if I use MKS, the chair is gonna look way out of scale relative to the dummy, right? So one of them will look way bigger than the other. So you have to make sure you export the chair model in the same unit as your dummy model. That's the first thing. Second thing here is that I want to generate a sort of like almost like a triangular acceleration thing to get it to a sudden stop. And so this is what I've done here. The global damping here, I'm just going to use a very small number because the nature of the dummy that exists, I'm going to make a really small number here. Now the initial velocity generation, you see this car replaces this object, and you notice how I have a 0, 0, 0 here. This will apply initial velocity of 30 meter per second across all of the body, including the dummy. So the dummy has not been included in here, but even when the dummy is included, this number will apply to everything that's in the model. Now this right here applies a triangular velocity. The reason I know it's a velocity because this parameter here is 0. So I know this is a velocity curve, right? And it's gonna start at 30 meter per second, and it's gonna go to 10 millisecond at that constant velocity, and it's gonna come to a sudden stop. So you're gonna start with a constant velocity, then a triangular downward deceleration all the way to 0 over 10 milliseconds. And that right there becomes an acceleration that is essentially applied to the entire chair plus the human body, and that's where the force is coming from. Okay, and that's the nature of it. Now this number, this node ID comes from the remote point ID. So I have to find out what is the node ID of that remote point. And the way you do that is with a script, a very simple script that I use. I've been using this script, just copy pasting it over and over and over. And what this thing does is that it tells you the remote point ID, which is 15274. And then what I'm gonna do here, and if you want to look into what the script does, is really simple. You just basically just access that object, and then find what the ID is. Nothing to it. Okay, and then so it's gonna be 15274. 15274. All right, so once this is done, that's it. That's all I have to do. Now, what I'm gonna do here is that, oh, I guess I should mention, I do have a couple of these in here. It may be valuable to include them. So full part. So let's go ahead and just do that then. Why not, right? I'm gonna call this the everything is a set part that I'm generating here through the name selection with a set ID 48, and the selection here is going to be this top piece. I'm gonna call this a set ID of 58. Okay, I might use them later, I might not. I don't even. But you just know I created these two sets. These are becoming part set. A set part list inside the input file. One has the ID of 48 that includes all 10 bodies of the chair. The other one is just the top frame. Okay. Now I'm done. I'm gonna save it. And then what I'm gonna do next is go ahead and export it out into my demo file. I'm gonna call this. You see, I already have some example file here, but I'm gonna call this the demo seat. Okay. All right. Here's the thing that I find that we have to look into, right? So, for example, if I were to load the demo seat in here, I want you to notice a few things, right? So you see how the part start with 1, 2, 3, 4, 5, and same with section, same with mat, right? But if you look at this file, if you look at the part file that exists here, right, it's also starting 1, 2, 3, 4, 5. So you see how we have a problem in which just the part, section, and mat are conflicting with each other in terms of their general ID. So now, as you know, what happens if I were to load both of them at the same time into LS-Prepos? We're gonna have a major problem to it. Just to prove that out, I can show you what happens, right? So you see here, I have this file. I'm gonna copy this file, and then I'm gonna turn it in here, and I'm gonna do an include file, and I'm gonna put it in here and call it .k. Now, if I were to load this file into LS-Prepos, we're gonna have a major problem, and that's the problem we have to solve in order to combine them, and we have to add a few more things in order to get this to work properly. Okay. Like I said, it's not necessarily the best way, but hey, it's worth looking at it because this is within what I have available to me. There may be commercial tool out there that can do this way easier. But if all you have is a workbench, this is what you can do. So let's take a look at what we can do. And if I were to look at, you can immediately see there's a bunch of errors on Stonewall saying that there's identity already exists and so on and so forth. If I do ignore all, and then you see a load, it's gonna give you something that makes absolutely no sense. Like, what is all this? You see that? This is essentially garbage. And the reason for this happened is simple, is because we have conflicting IDs. So how do we fix that? All right, so the way we fix this, right, is first thing, I'm not gonna do the include file yet. I'm going to, just for the sake of consistency, I'm going to comment this out and save it. So this include file does not exist anymore, right? And then I'm gonna drop the demo C into LS-Prep post. Um, okay, this is fine. Oh, I have a tight contact surface I didn't talk about, which is down here. I guess I already loaded out, so I'll explain what this is in a bit. Okay, I'll explain what this is in a bit. I already had it ready because that was part of my template from the earlier trial runs. All right, so this model is working obviously, and obviously if you look at in here into part, right? Uh, where's my part, man? Come on, all right there, right there. You can see 1, 2, 3, 4, 5, 6 all the way to 10. Okay. Now what I wanted to do is to rename everything inside, to renumber everything inside this preprocessor. So instead of having everything start at 1, I want everything to start at something that's extremely large, say 9,001, right? Or 90,001. 90,001, oh, this is actually 900,001, but this is the way I'm reading it. 90,001. 90,001, this ID is gonna be the starting point for everything I've selected. So node ID is gonna start at 9,001 instead of 1. You see we have 15,000 nodes in here, right? And then if I were to set this, the start ID here will become 9,001. And if I were to renumber, you see how everything got renumbered from 90,001 to whatever it was used to be, okay? Now, I do have a contact object that wasn't changed. I also have a boundary object that wasn't changed. We'll take a look at that in a second. Let's go ahead and close it. And now if you look at the file, you can see how everything is now renumbered properly, right? Now, what we do need to look at is that the boundary prescribed motion rigid, this number wasn't changed. Because this number is assigning to a CNRB, that does not change. So I have to change this manually to 900,011, right? And then I'm just gonna copy that and click accept, and I'm gonna do that for all the other ones. And this is one of those things, maybe there's a way to change this directly, but for some reason it's not changing, and it's pretty easy to fix. But just be aware, you want to double check what was fixed, what was not fixed with this tool, with this renumbering tool right here, right? If it wasn't changed properly, you want to make sure you change it. Okay, you can see the load curve is changed. Now the part ID is also changed. This is not good to go. Okay. And then I think the constraint node rigid body inertia, you can also see everything is changed, right? All the ID is changed. So this is all good to go. All right. So this is all we have to do. Now, if I was to just save, if I were just to exit out of here, and then before saying no, I'm gonna save the changes I made to the input file, right? And I want to make sure over here I don't have a double header, so I want to make sure I deselect my field name, and then click OK, and click Save, click Overwrite. All right, now let's look at what's in our new input file. You see now our new input file have everything changed to 900,001, 90,001. And then if you look at all the references, everything has been basically reorganized. And that's the awesome part of LS-Prep posts, right? You can do things that Workbench just cannot possibly handle right now. I don't know why it hasn't been implemented. I don't see why Workbench couldn't do what LS-Prep post does. This is just basically input file manipulation. I can probably write a code to do this myself. Otherwise, obviously, it wouldn't be trivial, but it's certainly doable, right? Certainly possible, but it's not available yet, so we can use LS-Prep post to do it. It's still pretty easy to do, as you can see. Okay, now what we can do is remember the include file I had earlier, right? I had already suppressed it. I'm just gonna unsuppress it. And now let's see what happens if I were to load this file into. Let's see what happens if I load this file into LS-Prep post. Do we still get that crazy error? I'm thinking not, right? I think that now this time it should work properly. So let's go ahead and do it. Put demo C in here, and then bam, I have my dummy model in here. Done, and okay. All right, you see here now everything is good. Now this model is basically ready to run. Now what was that contact card for? The contact card was so that I can pretend I have a seatbelt on here. I don't have a seatbelt here. I'm not gonna go try to model a seatbelt, right? There's no reason to do that. So I use the contact to bound basically a portion of the dummy model onto the chair, and I made them both rigid so that I can have that effect that you're seeing over here on this, like this kind of effect. The reason it's looking like this, even though you have no seatbelt, is because I bonded this back side and this bottom side, basically the butt onto the chair. I basically glue the butt onto the chair instead of having a seatbelt that does this. And that's really pretty much it. Now, if you follow me around, you probably will find a couple errors that I haven't specifically talked about, such as damping, such as how to do the contact properly. There's a specific contact setting you have to do to get the contact to properly glue to the chair, or you run into some problem. But I'm not gonna talk about that because that's a little bit beside the point. That's just basic LS-Dyna stuff, right? This is basically how to incorporate a dummy model. This is how you incorporate a car, incorporate a truck. It doesn't matter what it is, right? This is how you can incorporate a model that somebody else has built into your own model to work. And I just find that absolutely amazing that they can do this. I don't know. There's like Abacus. Maybe you can do this in Abacus, right? You can load a pre-existing Abacus file that can do this kind of stuff. I'm not a good at Abacus, so I'm not going to talk about it. But for me, being able to take a human body model that somebody else has created with all these joint behaviors to load it into a model, you have the proper weight, you have the proper of everything, is just so awesome to me. I just want to give a pause to the people who created this system. I love this system. Right, I'm gonna keep making Dyna videos, right? Because when I think about what I can do with just 20 minutes of my time to figure out how to do this, and the amount of things I can do to generate with the work that somebody did over 15 years ago, right? It just blows my mind. All right, so this is what I've said before, even before years ago. I've already said this, but I wanted to just take a moment to give applause to the people who has done this, who has created the software, because I love it. Okay, thank you very much. Hopefully this is very entertaining and helpful. All right, bye bye.